Hi everyone, myself Dr. M. Lakshmi Prasad, working as a professor in the Department of Computer Science Engineering at Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about graph theory. So the very first thing is that, what is a simple graph? So in this one, a simple graph G of V consists of non-empty set of vertices and set of edges such that each edge is associated with another pair of distinct vertices called as endpoints. And these vertices are adjacent if there is an edge connecting with the two vertices. An edge is incident to its endpoints also. So a simple graph is going to be defined as G of V comma A, which is nothing but set of vertices and edges consisting of non-empty set of vertices and set of edges such that where E should belongs to edge that should be associated with unordered pair of distinct vertices, so called its endpoint. And these vertices are said to be adjacent if there is an edge connecting with two vertices and an edge is incident to its endpoints also. And next one is degree. So what is the degree here? So if I'm going to consider a graph, so in this graph, so it should be a set of vertices and edges. So these should be called as vertices and this one called as edges or nodes and arcs. So how are we going to calculate this degree of the vertex? So the degree of vertex should be calculated. So the number of edges that are connected to the vertex should be treated as a degree of the vertex. So for this vertex V1, the degree of V1 equal to 3 because the three edges are connected to this vertex. So that's why the degree of V1 is 3. And what should be the degree of V2? So for this one also the three edges are connected. So the degree of V2 is also 3. So the degree of vertex in simple graph denoted degree of V should be the number of edges incident on it. And degree means that so the number of adjacent vertices. So handshaking lemma. So the theorem is that so in a simple graph G of V comma A, the equation is going to be divided by 2 into the number of edges should be equal to the summation of degree of V. That means that each edge contribute 1 to each degree of its endpoint. So thus each edge adds to its the total degree of G. This should be that. So each edge contributes 1 each to the degree of its endpoint. Thus each edge adds 2 to the total degree of G. Next one is what is a path and what is a cycle. So path is nothing but a sequence of vertices V0, V1 and V2 so on Vn. So when there is an edge connecting Vi and V plus I plus 1 for all I equal to 0 to n minus 1. And the path at the same starting endpoint is called a cycle here. So a graph is simple if there is no edges repeated, and acyclic graph has no cycles here. So the path is nothing but so if there is a graph like this, So the path is nothing but the sequence of vertices where the edge is connected, connecting vi and vi plus 1. So for all I equal to 0 to n minus 1. So the path can be estimated as v1, v2, v3, v4 and v5. So this should be the path from reaching v1 to v5. So this should be the source and this should be called as the destination. Similarly, what is the path from v1 to v3? Suppose I want to find the path from v1 to v4. So for that, the v1, v2, v4 I can able to go, or v1, v2, v3 and v4 also I can able to move. And what is the cycle here? So the path with the same starting and end point is called a cycle. So where the graph is simple if there is no edges repeated, and a cyclic graph has no cycle. So the graph which contains a cycle. So in this one, so this is the closed one. So this is contained a cycle. So this should be cyclic graph. A graph which does not have a cycle. So if it is the case, so then in this case it should be an acyclic graph. Okay. So whenever where there exists a closed loop in between the graph, and that should be called as acyclic graph. So whenever the no cycle exists between them, then it should be treated as a cyclic graph. So acyclic graph. And next one is adjacency matrix. So what is this adjacency matrix? So the adjacency matrix of simple graph G with n vertices is a binary of n by n matrix such that each entry I should be either 0 or 1. So the A of I equal to 0, that means if there is no edge from Vi to Vj, otherwise it should be 1. So the adjacency matrix of the simple graph, so with n vertices of n by n matrix, should be filled with 0 or 1 only. So if there is 1 means that there is a edge between one vertex to the other vertex, and if there is it should be 0, that means whenever there does not exist any edge between the two vertices, that is adjacency matrix. So the adjacency matrix, we are going to consider the number of vertices in the graph. So considering along with rows and columns. So if this is the graph means, so there exists an edge from v1 to v4, so that should be 1, and v2 to v4 and v3, and v3 to v2, and v2 to v4, and v1 to v2. So there is no edge, so that's why remaining all should be zeros. So this is what we call it as adjacency matrix. And next one is connectedness. So what is this connectedness? A simple graph is said to be connected if there is a path between every pair of distinct vertices. A graph that is not connected is said to be disconnected. A simple graph is called connected, so if there is a path between every pair of distinct vertices. So that means that a graph that is not connected is said to be disconnected. If I'm going to consider a graph like this, so there exists there exists an edge between for every pair of vertices. So that's why this should be a connected graph. So whenever there is no edge that is connected, then it should be a disconnected graph. So whenever there exists an edge between every pair of vertices, then it should be treated as connected graph. A simple graph is said to be connected if there exists a path between every pair of distinct vertices. Otherwise, it should be called as disconnected graph. And next one is that Euler's path. So, what is this Euler's path? A simple path that contains all the edges of the graph is said to be Euler's path. So, it is a path that contains all the edges of the graph in the path. If this path is also a circuit, what we call it as Euler's circuit. So the Euler's graph has Euler's circuits. So a Euler path is nothing but a path which containing all edges of the graph, and if also a path is a circuit, then it should be called as Euler circuit as well. So we set up all the edges. So that should be V1 to V2, V2 to V3, V3 to V4, V4 to V5. So this should be the Euler's path. And what is this Hamiltonian path? So a path is called as Hamiltonian path if it visits every vertex of the graph exactly once. So the circuit that visits every vertex exactly once except for the last vertex, so which duplicate the first one, is called Hamiltonian circuit. So, so this Euler path is somewhat different from the Hamiltonian path. So this Hamiltonian path means if it visits every vertex of the graph exactly once. So a circuit that visits every vertex exactly once, so except for the last one, so that should be called as Hamiltonian circuit here. So the visiting all the vertices of the graph exactly once, so without forming a circuit. So V1, V2, V3, V4, V5, again V1. So the visiting all the vertices of the graph exactly once, that should be called as a Hamiltonian path. A circuit is that so that visits every vertex exactly once except for the last vertex, which duplicates the first one, is called Hamiltonian circuit. And next one, what is the complete graph? So here a complete graph on n vertices, so denoted by k of n, which should be called as simple graph, so where each vertex is adjacent to all other vertices. So what is the formula for finding the number of edges in Kn? So the complete graph is going to be represented by notation Kn, so where each vertex is adjacent to all other vertices. So that should be called as complete graph. So whenever I'm going to have vertices, so for each and every vertex should be adjacent to each other. Similarly, if I'm going to consider V2, so V1 is already there, V3 and V4. So if I'm going to consider V3, so V4, V1 and V2. So this one what we call it as complete graph. So what should be the, so this should not be a complete graph, this should be a connected graph. And this should be a complete graph. So for every each pair of vertices should be adjacent to each other, then it should be called as a connected complete graph here. And what is a path and what is a cycle? So the path on one vertex is denoted by P of n. So it should be a simple graph consisting of a path, and n vertices have a degree 1 and all vertices in between them have a degree 2. A cycle on n vertices is a simple graph consisting of a cycle, so where each vertex has degree 2. So the path of n vertices, so is a simple graph consisting of path, and the n vertices have degree 1 and all the vertices in between have degree 2. So cycle is nothing but a simple graph, so denoting as C of n. So consists of a cycle where each degree has vertex 2. Suppose so this is the path. So the path is from V1 to V2, V2 to V3, and V3 to V4. So cycle means whenever the vertex is going to have a degree 2, then definitely that should be there exists a cycle here. So what is the degree of V1? That should be 2, and degree of V2 is also 2, and degree of V3 equal to 2. So then there exists a cycle here. And next one, special graph. So wheels and stars. So what is a wheel and what is a star here? So the wheel on n vertex is denoted as Wn. So it should be a simple graph consisting of a cycle and another vertex which is adjacent to all the vertices in the cycle. So the wheel on n vertices is nothing but a simple graph. So the consists of cycle Cn and another vertex which is adjacent to all the vertices in the cycle. And next one is the star. The star on one vertex is denoting is have any denotion. So what I'm going to say that, so it should be also a single graph consisting of n plus 1 vertices, and where n should be connected to n plus 1 vertex. So that should be called as a star here. And next one is bipartite graph. So what is bipartite graph? So the bipartite graph is a simple graph in which the vertices can be partitioned into two disjoint sets here. So like V1 and V2, and every edge is incident to one vertex in V1 and another vertex in V2. So the bipartite graph is a simple graph, so in which the vertices can be partitioned into two disjoint sets, where every edge is incident to one vertex and one vertex to V2. And what is the next one? Complete bipartite graph. So the complete bipartite graph means is the graph that has vertex set partitioned into two disjoint sets m into n. So whenever there is an edge between the two vertices, so if and only if the vertex one vertex is the first set and the another vertex is in the second set. So the each vertex is connected to all other vertices in the other subset. So the complete bipartite graph is the graph that has its vertex set so partitioned into two disjoint sets of m and n. So whenever there is an edge between the two vertices, if and only if the one vertex in the set and another vertex is in the other set. And next one is n cube. So n cube is nothing but called as hypercube. So here the q of n is the graph whose vertices are binary strings of length n. The two vertices are adjacent if and only if the bit strings are differ in exactly one position. So the n cube, what we called as hypercube, denoting as q of n, which should be also a graph where vertices are binary strings of length n, and the two vertices are adjacent if and only if the bit strings are differ in exactly one position. And next one is that regular graph. So regular graph means if each vertex of simple graph has a degree k. So if each vertex has a very simple graph has degree k, so that the graph is called regular graph. So if each vertex of the simple graph has a degree k, then the graph is called regular graph. And next one is that isomorphic graphs. So the two graphs, so said to be V1, G1 and G2 are said to be isomorphic. So denoted as G1 and G2. If there is a one-to-one or onto function such that if V1 and V2 are adjacent vertices in the graph G1. So the two simple graphs, so G1 and G2 are isomorphic. So denoted G1 and G2. So if there is a one-to-one or onto function, so such that if such that V1 to V2 such that the V1 V2 are adjacent vertices in graph G1 and at the same time also in graph G2. So the edges are going to be preserved, and then the number of vertices and number of edges and degree of the vertices cycle longest path are all are invariants under the isomorphism. If any of these quantities are differ in two graphs, they are not also as well. So these isomorphic graphs should be uh, denoted as G1 and G2. So whenever there is exists a one-to-one on. Next one, what is the planar graph? So a graph is said to be planar if there is a way to draw it on the plane without the edge crossing. So whenever I'm going to draw a graph on the plane, so where the edges does not cross each other. So if I'm going, this should be a planar graph. So the graph what is drawing on the plane where the edges does not cross each other, then it should be a planar graph. Suppose I'm going to draw a graph. So this should not be a planar graph. Since here the edges are intersecting each other, so due to this, there should not be a planar graph. So such drawings, what we called as planar representation, which splits the region into two regions. So these planar graphs are also relatively easy for humans to grasp, and since there is no cross edging, and sometimes the edges of the planarity are more concrete. For example, when wires are arranged on the surface like a circuit board or microchip. So these planar graphs is what is the graph that is drawing on the plane without edge crossing. So that kind of thing what we call as a planar representation. And these planar graphs are relatively easy for humans and there is no crossing edges. So when the wires are going to be arranged on surface like a circuit board or mic. So for the connected graphs, so they start with the vertex and record the phases while drawing, and phases are going to be enclosed in circuits, and the precise rules are going to be defined. The cycle that are the phase boundaries of the planar diagram. So attach the each edge from one vertex on a face to new vertex, and second one is attach an edge between the two non-adjacent vertices on a graph. Okay, for the connected graph, so we have to be a start vertex recording the faces as well, and these faces are going to be enclosed by circuits. And Euler's formula. So the Euler's formula, if there is an connected planar representation of the graph has vertices v and then n set of edges, then the faces is going to be denoted as v. So b plus b minus e plus f equal to 2. So if a connected planar representation of a graph has v vertices and e edges and f faces, then the equation is going to denote it as v minus e plus f equal to 2. So the proof is that, so for the base case, if there is a no edge, then we have one vertex and one face, so which is going to satisfy the equation. So assuming that there are n number of edges, that is going to be denoted as e minus v minus e plus f equal to 2. So if I'm going to add an edge, so let it attach to the new vertex or it will be a old vertex. So for the first ones, once we choose a face and edge with a new vertex, then it should be denoted as, so v plus 1 minus e minus 1 plus f equal to 2. So on the other hand, we're also going to be choose a face and add an edge across it. So that should be also written as v minus e minus 1 plus f equal to 2. So finally what I'm going to get is v minus e plus f equal to 2. A simple graph is a tree. So if every pair of distinct vertices has exactly one path, so is the tree connected, and tree also have cycles. So a tree is also a graph, so which is going to have set of nodes and edges, nodes and childs. So this should be also a graph. So for each pair of distinct vertices have exactly one path, and tree is also connected one and does not have cycles. And next one is coloring. So coloring means that, so the assignment of color to each vertex such that no two adjacent vertices is going to have the same color. So a graph is k colorable if each vertex can be assigned one of the k colors, so that the adjacent vertex going to get different colors. So the coloring of simple graph is the assignment of coloring to each vertex such that no two adjacent vertices is going to have the same color. And the graph is said to be k colorable if each vertex is going to assign one of the k colors such that the adjacent vertex is going to have different color. So in a graph, I want to coloring the graph. So if I'm going to assign with blue color here, the next addition node should not be that the same color, should be the different one. And next one, so here I'm going to use the red color here. So which color I can able to fill this? So if I'm going to assign blue, it should be possible. Then shall I go for green? Yeah, green. So like this, we are going to be assign the color to the different vertices of the tree, and that should be such that no two adjacent vertex should have the same color. So the minimum assignment color should be k upon what we call as chromatic number. So the maximum number of colors that are minimum number of colors that are as needed for representing the graph should be denoted by k of n. So here the graph is k colorable if each vertex can be assigned to one of the k colors so that the adjacent vertex should get the different colors. And next one, digraphs. So a digraph is also called as a directed graph or digraph. So it should be denoted by d or is equal to x of a. So consisting of non-empty sets of vertices and set of arcs such that the A should belongs to A that should be associated with ordered pair of distinct vertices. So a directed graph or diagram is going to be denoted as d of x of a, which should be consist of set of vertices and then set of edges. So if I'm going to draw a graph, so where the edges is going to have the directions. So I have an edge. So this should be the directed graph. and they should be also be directed graph. So what is this in and out degrees here? So when I'm going to have an edge of the graph, so then U is called initial vertex and V is the terminal vertex. And in the directed graph, the end degree of the vertex V can be denoted by degree of minus V. That should be the number of edges with V as the terminal vertex. And similarly, the out degree means denoted by like this, and it should be the number of edges as an initial vertex. So that means in the graph, if I'm going to draw it, so the total degree of V should be denoted by degree of V plus degree of minus V. So that should be the summation of out degree plus in degree. That should be the total degree of that vertex. So if I'm going to draw a graph like this, so what is the in degree of A? Only 1, and out degree of A only 1. So for C, so in degree of C is 0, is also 1, and out degree of C is also 1. Like this, we're going to calculate. So what should be the degree of A? That should be 1 plus 1, that should be 2. Similarly, the degree of C, so 1 plus 1 equal to 2. So the set of neighbors of the vertex V and then vertex V itself is called vicinity of the vertex. That should be denoted by N of V. And a vertex is a source if it has no neighbor and is an in neighbor of at least one vertex. And vertex is a sink if it has no out neighbor and is an out neighbor of at least one other vertex. And next one is directed path. So what is the directed path? So the directed path of length n from U to V in diagram is the sequence of points such that U is equal to V0 to V and that should be equal to V. So whenever there is an arc connecting from two vertices Vi and Vi plus 1, so that should be called as a directed path. So whenever I'm going to have an edge that should be connected with an arrow, so that should be called as a directed path. So V3, so this should be also directed. And the path with the same starting end points form a cycle or circuit, and the directed path is simple if there is no edges. So the directed path of length n from U to V in the diagram is nothing but a sequence of points, and the path with the same and starting end point is called a cycle, and the directed path is simple if there is no edge is going to be repeated. And next one, connectedness. So a diagraph is strongly connected if there is a path from A to B and there is a path from B to A. So whenever the A and B are the vertices. So a diagram is said to be strongly connected. So whenever there is a path from A to B and then from B to A as well, and where the A and B are the vertices in the graph. Suppose if I'm going to have a graph like this, so this should not be a connected diagram. So whenever there is an edge like this, then it should be called as connected diagram. And similarly, the previous one should be treated as weakly connected also. There is no edge from B to A, so that's why weakly connected. There is no edge from C to B, so weakly connected, and there is no edge from A to C. That's why it should be weakly connected graph, and this should be strongly connected diagram. Our next one is trans to diagraph. So what is the trans to diagraph? Is also a diagram which should be denoted as d of v comma v such that for every any three vertices u v such that the x should be belongs to v. If there is an edge from u to v and v to x, then it should be directly related to u to x. So the underlying undirected graph or trans to diagraph is called compatibility graph. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.